So for section 2.2, we're going to look at the multiplication property of equality. Very similar to the addition property. I can add anything to both sides, it stays the same. I can also add negatives, i.e. I can subtract on both sides and it stays the same. I can also multiply. See, I can multiply anything to both sides of the equation and it stays the same. If I have A equals B, I could multiply both those sides times C and they would still stay the same. See, look, if I've got 5 equals 5, that is a true statement. If I multiply both sides by 2, I end up with 10 equals 10. It's not very impressive, but just because I multiplied by that C didn't change the fact that both sides were the same. This also works if I multiply by negatives, which is important. 5 times negative 2 gives us a negative 10. 5 times negative 2. The sides stay the same as long as what I do to one side, if I do it to the other, the sides will stay the same. Why is this important? Well, we're solving for x. 5x equals 60. You're like, okay, I know 5 times what makes 60. That's on my multiplication table, right? That's fine, but how do you solve it? Well, we're going to use inverse operations. This is 5 times x. What is the inverse of multiplication? What cancels out multiplication? The opposite of multiplication is division. If I divide by 5 on one side, to keep equality, I do it to the other. So the 5's, 5 divided by 5, they don't make 0. Anything divided by itself makes 1. So I end up with 1x, or just x, equals 60 divided by 5 is 12. You're like, well, wait a second, I thought you said multiplication property and we just divided. Well, there's another way of thinking about it. This is not going to be the way I want to solve this. But you can actually deal with multiplication by using multiplication. What you do is you multiply by the reciprocal. Instead of multiplying by dividing by 5, I could multiply 5 over 1 by its reciprocal. The 5's would still cancel, leaving me with x. And if I do it to one side, I do it to the other, I end up with 60 over 5, or 12. So there's two ways of thinking about it. You can undo multiplication by dividing. Definitely I want to do that when it's easier, which it was on this one. But I could also divide or multiply by the reciprocal, and it's the same thing as dividing. Negative 25p equals 30. Here's what makes me sad. Some people will do this. You're like, yep, I did it to both sides, must be true. This makes me sad because that negative 25 is not subtraction. What is that negative 25 doing to p? It's negative 25 times p. You do not undo multiplication using addition or subtraction. It is utter nonsense. To undo the multiplying, the inverse of multiplying is division. And so I would divide both sides by. Now this is a mistake too, and here's why. I know the 25's become a 1. But I'm left with that negative. I don't want my answer to be negative p. That doesn't help. Okay? So what I do is if p is being multiplied by a positive, if x is being multiplied by a positive, we divide it by that positive. If the variable is being multiplied by a negative, we divide by the negative. So that the negative and negative now make p positive, which is what we wanted. And this can be simplified. 30 and 25. A positive divided by a negative is still negative. And I think they're both divisible by, it looks like, 5. 30 divided by 5 is 6. 25 divided by 5 is 5. And so, negative 6/5. There must have been a mistake. The answers are always whole numbers. Nope, not this time. Now we got a fraction, or a decimal if you like. Is it right? Well, let's check. Let's take that negative 6/5 and put it in place of the p. Here's what I know. A negative times a negative is a positive. I also don't want to do 25 times 6. I can do 25 times 6, get 150 divided by 5 and get the answer. But what I like to do is I like to cancel the 5 into the 25. See, the 5 goes into the 25. I can divide it in 5 times. So I'm left with 5 times 6 is And I believe 30 does equal 30. So that means that scary fraction was our answer. What if it's a decimal? Right? You freak out and give up. No, 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 no. We can handle this. Now keep in mind, I'm expecting you to be using technology on these. So what do I need you to know? You need to know that x is being multiplied. And so to undo multiplying by 2.1, the inverse of multiplying is to divide by the same number. And if I do it to one side, I do it to the other. Now these, once again, they cancel. They don't make 0. They make 1x, or just x. 6.09 divided by 2.1 is not fun. So we take 6.09, we divide it by 2.1. You don't have to use this. Please feel free to use the technology. Now how do we divide by a decimal? I got 2.1, right? Short answer is we don't. That is complicated. We don't like to divide by a decimal, so we move this over, and then we move this over. Why can we do that? Like, I don't know, my teacher told me, I got my gold star, and we moved on, right? But what you're doing when you're moving the decimal over is you're basically multiplying that 2.1 times 10. Can I do that? Just multiply something by 10 because it feels good? Now keep in mind, I can do anything, right? If I multiply it to the bottom and I multiply it to the top, I'm basically multiplying by a 1. I'm not changing it. I'm just making it easier. I'm making it 60.9 divided by 21. Deep thought, so maybe you've never thought of that. That's okay. 21 into 60, I believe, goes in twice. 2 times 21 is 42. 18 with a 9. 21 into 189. Let's just go 2 into 18 is probably about 9 times. So we'll try 9. If it's not right, we'll keep going. 9 times 21 is 189. Do not forget to bring up the decimals so that our answer is 2.9. You will be expected to handle some more complicated things. Just because they're decimals doesn't mean the rules change. Okay? This is what we were talking about a second ago. Please don't do this. This makes me sad. Negative 6x. Do not add 6. The opposite of multiplying is not addition. You'll end up with negative 6x plus 6. Those are not like terms. They don't combine. Equals 18. You've actually made the question more complicated by trying to add 6. Don't do it. Okay? How do I deal with that multiplication? Division. Make that connection. That's probably the most common mistake. It gets to be really frustrating because you're doing really well and then you start dealing with multiplication using addition and throwing away good points. How do I deal with division? Well, we dealt with multiplication by using division. So how about we deal with division by using the inverse multiplication? What will I multiply by? Well, x is being divided by 4, so I'm going to multiply both sides by the 4. On the left side, the 4's cancel, leaving me with x equals 12. And obviously we could check that answer. The 12 divided by 4 gives us 3. But I mean, that's just something to keep in mind, that to undo multiplying we use division, and to undo the division we use multiplication. They are inverses of each other. Now here's where things get a little complicated, because there's two ways to approach this, and I'm going to show you the left way, and it's kind of the way I was taught. Then if you prefer the right way, I've seen a lot of students do the right way, and we'll talk about it. But here, 3/4 n equals 6. N is being multiplied by 3/4. So I'm looking at this going, or maybe it's an h, I don't know. But the idea is, how do you undo multiplying by a fraction? And you're like, I don't know, divide by a fraction? That's not fun. It is not easy to divide by a fraction. You could do that, and there's ways of dealing with that. But there's an easier way, and this is where I go back to what we were talking about at the beginning. Where was it? We said, well, dividing is the same thing as multiplying by the reciprocal. And you're like, that was utter nonsense earlier. But that might help here, because I don't want to divide by 3/4. But what if I multiplied by the reciprocal? What is the reciprocal of 4/3? Well, that's where the fraction flips, right? And you don't change the sign. Not the opposite. You just do the reciprocal. And if I multiply by 4/3 on one side to keep it equal, I do that to the other side. What does that do for me on the left side? Well, 4/3 times 3/4. The 4's cancel, the 3's cancel. You're like, wow, that easy? Well, if you didn't see that, multiply them together, you get 12 divided by 12 is 1. So I'm left with h equals. Now how am I going to do this? I could do 6 times 4 divided by 3, but I prefer to divide the 3 into the 6 2 times, so that 2 times 4 is 8. Okay? Yes, I could have made that 24 divided by 3 is 8, but either way, we get the same answer. Okay? Here's the other option, and the one on the left is what I was always taught. I was taught multiply by the reciprocal, and that's fine. But I have found that some students don't like that, or they start doing some really weird things when they multiply by the reciprocal. And so here's what they look at. They go, h is being multiplied by the 3, and that 4 is on the bottom, so it's kind of being divided by the 4. And so they go, you know what, I'm going to do this as 2 separate steps. I don't like the fraction. I don't like the division. So what if I just multiply both sides by 4? Could I do that? Well, sure. On the left side, the multiplying 4 and dividing 4 would cancel, leaving me with 3h equals 6 times 4, 24. And last, now h is only being multiplied, so the inverse of that multiplication is division, so that h is equal to 8. This is supposed to say multiply, then divide, sorry. So, did it change the answer? Still got h equals 8. You're like, yeah, but the left way is the way my teacher taught me. Okay, that's fine, I get it. Same thing here. But what did we do when we multiplied by the reciprocal? Basically, we multiplied by 4 and divided by 3. And so somebody over here goes, I'm just going to multiply by 4 and divide by 3. They added a step, but they are really doing the same thing. So it's not a big deal. If you prefer to multiply by the reciprocal, I get that. If you prefer to multiply by the 4, then divide by the 3, I get that. There's nothing wrong with either way. Okay? So this is called the multiplicative inverse. That's a big scary word, but that's basically where we multiply by the reciprocal on both sides. Well, what if it's fraction? I don't know why I have that. I'll get to that in a second, though. Here, t is being multiplied by negative 5/6. So on the left side, if I multiply by the reciprocal of negative 5/6 is not 6 over 5. Keep in mind, the reciprocal means it flips, but the sign stays the same. I want that negative to be multiplied by a negative, so I end up with a positive t. Okay? So you need to verify if I'm multiplying by a negative, then I'm going to multiply by a negative with the reciprocal. Okay? What we do to one side, we do to the other. So what are we going to do here? Let's see. The 5's cancel. The 6's cancel. The negative times the negative gives me positive t equals. On the right side, I can do 15 times 6 is 90. 90 divided by 5. Totally nothing wrong with that. I'm going to divide the 5 into the 15 3 times. A negative times a negative is a positive. 3 times 6 is 18. So just t equals 18. I've got people that don't like that. They're like, that was way more complicated than I want to do. That's fine. So here's what they're going to do. On the right side, they're going to go to undo the division. We're going to multiply by the 6 first and get negative 5t is equal to negative 90. And then last, they're going to divide and get the t equals 18. Did the answer change? So do what you're comfortable with, please. Another little side note, if I got negative x equals negative 4, or if I have negative x equals a number, how do I undo that negative? We kind of talked about this earlier, but this is like a negative 1 times x, right? The inverse of multiplication is division, and you divide by the same number that we're multiplying by, so that the negative divided by a negative makes that positive x, and the negative divided by a negative makes that positive 4. So if you have a negative x, we basically just can divide both sides by negative 1 to make it positive, and then it changes the sign of the other side. Couple more complicated. This is where I encourage you, go ahead and, pause it, work these out, and then check your answers. If you feel comfortable with that, it's your choice, but remember, you should be practicing these and kind of checking what your mistakes are right now before you start the homework. So this is very similar to what we had before. I have two variables that are on the same side, 7m minus 5m, so we can simplify by combining like terms. Notice I don't need to add 5 this time. They are on the same side. So I can combine 7 minus 5 is equals. Now, m is being multiplied by 2. So the inverse of multiplication would be to divide by, so that m equals. Same on the right. Okay, so we did what? We simplified, and then we undid the multiplication by using division. Okay. On this one, combine the like terms. 4 minus 9, negative 5r. You need to know your integers. R is being multiplied by a negative 5, so the inverse of multiplying is to divide both sides by, not a 5, a negative 5. If it's being multiplied by a positive, we divide by a positive. If it's being multiplied by a negative, we divide by a negative, so that we end up with positive r equals positive divided by negative is a negative. 20 divided by 5 is 4. Same process, one with a positive, one with a negative. Doesn't need to be any more complicated than that.